Okay, I'm taking the quiz. 19 minutes. 19 minutes. Viable alternatives. Phoenix, average yearly precipitation of 9 inches. 18 million ESAL's properties are as follows. Structural layer coefficient. Okay, structural layer coefficient. 0.42. Resilient modulus of base course material is 30,000, subbase 10,000, resilient modulus. Okay. Minimum thickness of the asphalt concrete layer. Okay, so I've got to input this into the equation. So I have the book open on my other screen. Standard deviation of 0.35. Reliability of 91%. And I have all of this stuff ready to go. Reliability of 91, so that would be negative 1.34. Negative 1.34. Negative 1.34. Negative 1.34. Structural member, I'll get that. Is it a major highway or a downtown Phoenix? Definitely counts as a major highway to me. So I will use 2.5. Average resilient modulus. What do I take? Okay, I'm looking at the homework that I did last time. Because this 0.42, that was the A1. A1 would be 0.42. Okay. MR is the average resilient modulus of the subgrade. Average resilient modulus of the subgrade. 5,000. Okay, now time to go to E2, resilient modulus of the base course material. Resilient modulus of the base course material, 30,000. 1, 2, 3. Okay. E3, sub-base course material, sub-base course material, sub-base course material. 10,000. 2, 3. Okay. Okay, both of them show good drainage. Good drainage according to good drainage. Okay, good drainage. It's in Phoenix. Phoenix never gets rain. Average yearly precipitation of 9 inches. That's, I would say, less than 1%. It's in Phoenix. Less than 1% good drainage. I'll go 1.35. 1.35 for both. 1.35, just because it's within the bounds. Okay. I found a typo right here. Should get extra credit. So I'm gonna copy this. And how many? We got 3 bids. Okay. So the first one, 8, 11, 8 inches, 11 inches, 6 inches. I'm not even gonna look. 8, 6, 16. And then we got 7, 10, 13. And the structural number, I'm just gonna put is equal to that. Paste. Are those two the exact same? Huh. And what's my goal here? How is it that these are exactly the same? That don't make sense. 18 million ESALs. 18. Okay, I'm getting that all of them work, but that's not the answer. I don't know, something's not right here. Reliability of 91. Reliability of 91. Negative 1.34. Yes. Standard deviation of 0.35. Yes. Structural number, whatever that is. It is a major highway. And the MR, the average resilient modulus. How much time do I have left? Come on. 11 minutes. Okay. Thousand, 10,000, 0.42. Where did I get that 0.42? No. Eight, 6, 16, 7, 10, 13. Let's compute the minimum thickness of the asphalt concrete layer, the base layer. I'm getting that all of them work. Let me try. Total value of, what was it, 18 million? 18, yeah, 18 million. 1, 8, 1, 2, 3, 4, 5, 6 by changing variable cells. That one, that one, and that one. Let's see what happens. 7.9, 10.9, and that. So this one would work. That one would work. That one would work. I don't think that one would work. Could just be A. Okay, I'm gonna try it again. But by changing, boom, boom, boom. 7.9. Yeah, 6, 16. Okay. Boom, boom. 7, 10, 13. I'm getting that all of these could work. And this says right here, you must compute the minimum thickness of the concrete layer, and I know that Solver goes close to the next inch. So I'm just gonna round up. 8, 11, 6, which is A. A works. I know that A works. Let's go 8, 6, 16. I also know that B works. And then 7, 10, 13. I know that C works. All of them work. Okay, that's officially my answer, is that all of them work. I'm gonna click B and C, although I wish I could also click A, but I think that this might be a mistake, so I hereby submit. Here's my Excel sheet proving that all of them work, and they are all viable alternatives using the final Ashto equation. I rest my case. Submit.